Welcome, everyone. Happy Juneteenth. Thank you for joining us on hopefully your day off, I hope. Today is the fourth day of Black and Data Week. And as everyone is learning, today is about artificial intelligence. And we have two presentations, the first of which is with William. He's a staff software engineer at Meroxa. I hope I'm saying that correctly. He has worked as a full stack engineer writing tools for subject matter experts in climate science, solar energy, and I love this, basketball analytics. He advocates for increasing diversity in tech by mentoring engineers like he is doing today from underrepresented groups. So thank you, William. I will let you take it away and do your thing.
Yeah, thank you, Sia, and thank you to Dr. Kim and the entire Black Ties group for having me. Like I said, I followed Black and Data Week for a while, followed Black Ties for a while, so I'm excited to be able to participate and hopefully everyone can get something out of this session. So I'll jump right into it, just in the interest of time. So yeah, my title of the talk is Beyond APIs, Building Interoperable AI Systems with MCP and A2A Protocols. And then, yeah, as Sia mentioned her Juneteenth representation, I'm representing with my design of my slide deck and also with my shirt. Got a little hard to see, but yeah, Africa, the continent of Africa formed out of binary. All right. So yeah, there's my speaker intro, which Sia has already covered. I'm a staff software engineer at Meroxa, been around for a while, and the different things that I've worked on. So we're gonna try to level set the goals and expectations for today is that we want to be able to introduce two emerging protocols for working particularly with AI agents, and that is Model Context Protocol or MCP for short, and Agent to Agent or A2A for short. And we're gonna see what each one of those protocols do and how those protocols can be complementary to each other. So we're going to see how we can use MCP in a multi-agent system, but we're not going to write our own MCP server in this particular workshop. So in this case, just in the interest of time, I'm not going to live code it. I already have like the code written, but we will walk through the code. It's fairly short, so we'll see how that is behaving. So our overview, we have one, why do we need these protocols? Why do we need these protocols to define how agents can interact with one another? So we'll, again, level set why we even need to learn about or why these protocols were even created. Then we'll look a little deeper into each one of the protocols, what they are, some of the concepts behind them, and how they can be used. So then we'll look at a couple of use cases of building out systems using them, and then we'll have a little fun with the demo. I hope that everyone will get something out of. All right, so starting from the top, let me see. I don't know if this is, I can see it on my screen. I just want to try to make sure it's not. Let me see if I can hide the.
Yeah.
Is that visible on everyone else's screen?
What are AI agents? We can see it.
Oh, well, I'm meaning the Zoom strip. Let me see if I can just hide the control panel. Let's see. Okay, there we go. It was just blocking part of my screen. I wanted to make sure it wasn't blocking anyone else's screen as I was sharing. So, what are AI agents? AI agents are autonomous pieces of software that are mostly powered by large language models or other forms of AI, different models out there, but they can particularly try to perceive, reason, and act within digital environments. So there's been a lot of talk about AI agents and that being kind of like the new wave right now. Everybody's trying to integrate them, everybody's trying to learn about them, everybody's trying to see how they can, and augment or improve their workflows. So as we see on the screen, they can do several different things. They can plan out actions. They can invoke tools or APIs to complete tasks, which we'll see more as we go through the rest of this presentation. But one of the most powerful things, I think, in my opinion, is that they can collaborate with other agents on a common task. So you can think about building out teams of agents to interact and collaborate almost like, we do. A previous project I did, I basically created a team of agents to interact as like a research team where you had one agent that would go out and fetch data as like a researcher. Then that agent can pass that information that it went and got to a writer agent, which then can write up a draft, and then that agent can then pass to an editor agent, which would then critique and criticize the draft to try to make it better. And you could actually have that operate almost in a cyclical fashion until you get a desired output. So that's all well and good, right? So it's really, really cool some of the stuff that agents can do. But as with any type of new emerging technology, there's going to be new challenges that come along the way. So most of us are probably already familiar with like chat interfaces like ChatGPT or Claude or Perplexity or things like that. And we're mostly already familiar with prompting, right? Well, with agents, they also take prompts. But one of the things that agents can do is that they go out and use tools. So whenever you're using a tool, you almost, if you want to think about it, if you have a background in like more traditional web development and distributed systems, you can have a client and you can have a server. So you can think about, client can be analogous to an agent, server can be analogous a little bit to a tool. Those two, there's a contract in the middle, mostly designed, by API later that can define how they can interact with each other. So you want to keep them decoupled. Currently, before these protocols came out, agents were more tightly coupled with the tools that they used, meaning that whenever you want to prompt to use a tool, you almost had to embed some of the logic to use that tool into the prompt, which is very brittle, right? Because let's say something on the back end or with the tool that you're trying to use changes. Now your prompt doesn't work anymore. So it was too tightly coupled as far as trying to, build something, maintainable and sustainable. And along with that, kind of ties into it, there was a lack of standard interfaces between agents and the tools that they were trying to use. Again, going back to that traditional client server, web model, I can have a client over here. Again, we have the API that defines a standard interface of how it can interact with a server. Something on that server can change, but as long as this API remains the same, it doesn't break any of the clients that's trying to interact with it. And there was nothing like that for AI agents. So if something changed as far as trying to interact with the tools, then your agentic system would break down because like first really with no changes in your own code, right? It's just the code, the tool or the service that you were trying to interact with could change and update, and now your system could be broken and going down. And it also poor interoperability where we established in the previous slide that one of the biggest advantages or concepts or agents is them being able to work together. But there was no easy like or standard interface for allowing these agents to work together all the time. So again, it was a lot of every time you were trying to build an agentic system, you're also stuck with trying to create a lot of the just infrastructure around the system that you were building versus using standard tools. So this is where MCP comes in. So again, MCP, Model Context Protocol for short. It was created by Anthropic. So Anthropic is the team behind Claude, which is one of the most popular commercial generative AI chat products out there. And what it does, it defines a standard for AI models to be able to query tools, memories, and APIs. So trying to solve some of those problems from that previous slide. So again, we want to separate what the agent, like the prompt logic, from any of the tools implementation. So we see that like with we want to, again, have those separate concerns, right? The agent should only worry about the what, as far as like, hey, I want this thing, I want this information, or I want to accomplish this task. The tooling and the API or the the tool on the back end should determine how that's done, and they should not necessarily have to cross over. Okay, again, for those reasons that we talked about before. One analogy we could think about with this is almost going up and say like almost like a coffee shop or some type of restaurant where if I'm going, I don't drink coffee, but I drink tea. If I go to like a coffee shop or whatever, if I want to order a tea, that's the what, right? I want to order a tea. And so then that's me. You can think about it as the agent or the client or whatever. And from the back end of that, I give that order to the barista. The barista worries about the how as far as going and making the tea. Now, they can completely change their process of how to make the tea, but that doesn't change how I operate as far as ordering the tea. So, if that makes sense, I hope that does. It's like on my side, I'm worried about one thing about what I want to accomplish and how it's accomplished on the other end shouldn't necessarily, well, again, analogies break down if you scrutinize on the reverse, right? Because I want my tea at least made safely and hopefully it tastes good. But how they do it shouldn't necessarily be any of my concern. And that's how we are able to separate the concerns like in this agentic flow. So now also, as we're going to go to this next slide and see the different components of MCP, we're going to see how this fits in to different things. So you have a MCP host. So that can be something like Claude Desktop. It could be something like an IDE, like particularly I use Cursor a lot. If you are not familiar with that, it's a fork of Visual Studio Code that basically has integrations, a chat integration that can interact directly with large language models. Windsurf is another one that's similar. So these are the MCP hosts, and those hosts have MCP clients embedded in them. So the clients are just like clients again we may know from traditional web servers. They're the ones that create the one to one connection with the servers. And those clients, once they do connect with those servers, they're the ones that's sending the request first to that server, and those servers then have specific capabilities that are exposed, again, similar to like a REST API, that can then go and interact with different data sources. So in this case, we have two different type of data sources that we can interact with. We have a local data source, so those are things that's like located directly on your file on your local machine. So things you can think about that you can access through like local host. So whether it's just local files, like a database that's running locally on your machine, or any other services that you can access that's like right there on your machine. And then we have like those remote services. So things that you're going to be able to access through a web API. So whether it's through like a RESTful request, through like gRPC, GraphQL, or anything like that. So we're going to see a diagram in the next slide as well of just how all of this ties together. So just a visual breakdown of what we just talked about. So we have the host over here, and this has the client within. So then we see we have three different servers. Each one of these servers defines a standard interface of how to interact with a particular type of data source. So in this case, we see we have server A. You can think about this as maybe being like local file system. Maybe this is just just a file server where it can find a file on your local computer. There's like a text file or something. Open it up and read through that file. So instead of us having to write that interaction ourselves, we can write this server that can be reused in multiple places, so that now if we have a prompt that comes over here from one of the clients and say like, hey, find all the files on my computer that is like all the different rental leases I've signed over the years for apartments or something. It can go and find those, maybe by some type of grep pattern or something like that, define all of those leases, going and so it goes over here to your local file source, finds those, and then then return the information about those back to you. So it's a way of being able to interact with data that it doesn't currently know about, because that's one of the limitations of large language models, right? Is that they only are able to, in a non-hallucinogenic way, give you accurate information about data that they have been trained on. And for the most part, if we're sticking with that example, a data set around leases that I've signed for different apartments is not going to be, at least I hope not, in a data set that a large language model has been trained on. So if I want to be able to use data, fresh data or data that it's not aware about, this is a way to be able to do it. And if we look down at server C, this is actually then using the remote service. So this is being able to go out and get fresh data from the internet, or some other mostly from the internet, but something just remotely where you can go and fetch data from. And we're going to see an example of that once we get into the code phase. I typically like to go on through, but feel free. Like, I know I've covered a lot thus far, and I'm talking a lot. So if anyone has questions or confused about something, please drop it in the chat, raise your hand or something like that, and I'll try to get to it as best I can. But we have another diagram here, and some of this we've already covered. Why does it matter? So we've covered this quite a bit in that, one, we can decouple the tools from the prompts, right? Just to make the systems more maintainable. It promotes that modularity and reuse, because again, one of the challenges with writing AI agents as they were especially just really starting to become popular is that every time you want to create an agentic system, especially if you need to interact with some external data source, you are writing that that interaction for the most part yourself. But now with standards coming up, let's say if you wanted to interact with a Postgres database, which we'll see in a little bit, if I had two different agentic systems I was trying to build, I would have to almost build that interaction to integrate with Postgres two times, or like copy this or paste this code over or something. But now with these protocols coming up, you're having just basically almost like reusable packages that you see pretty common in most other programming languages, right? Or programming paradigms, where I can just go and download this MCP server for Postgres, and I don't have to worry about reinventing the wheel every time I want to interact with a Postgres database with an AI agent. And the composability is that we saw in the previous diagram, we have now multiple MCP servers that we can use to interact with different data sources, so we can start to compose these more complex systems without having to, again, recreate the wheel every time. And one of the other ones that I think is important that we'll see a little bit of as well is improving observability. Because from there, with AI, a lot of times, especially with the generative AI world that we're living in right now, sometimes things are a black box, right? For better or worse. When you make a request, it goes out and does some stuff, you have no idea what it's doing, and it gives you back something. With building these type of systems with a tool that we're going to see in a little bit, we actually get a little bit of observability as far as like, okay, we can see the workflow as far as it, the prompt hitting a particular MCP server, it's using a tool, the request coming back, and then we're seeing just the kind of the chain of thought that's happening throughout the agentic system. So that was a lot about MCP. And what we're going to cover now is that next protocol that's emerging is agent to agent, or A2A for short. So this one was created by Google. And initially, I thought these were competing protocols, but they're actually quite complementary. So if we remember MCP, we were primarily working with external services and tools, right? Well, A2A works on a similar concept, but it's actually for communication between agents themselves. So they provide a standardized and secure protocol for agents to be able to communicate with one another and delegate with each other. So you can almost think about like it's forming a sitemap. So you think about like you don't feel like you don't see them that often anymore, but like sitemap for websites, where it kind of links to all the different web pages that are available, or pages that's within this website. This is kind of a similar concept for agents if you're building out agentic systems. So you can have multiple different agents, and it allows them to discover one another within this kind of almost like knowledge graph, and seeing how they can interact and collaborate and delegate between each other. So some of the core concepts of agent to agent is first having an agent card. So this is almost like a business card you can think about for an agent. So it defines like, hey, here's my name, here's my capabilities, and here's the endpoint in which you can access me at. And from there, you have the inbox endpoint. So this is where you can make a request in this agent and send structured messages to it, where you can basically communicate and pass data between these agents. And then passing those messages, it could have a JSON payload that can specify a specific task or message to delegate. And then it also has message signing for security. So, as I mentioned initially, as I was, again, I definitely won't call myself an expert in these, but as I was learning about these protocols, I was like, oh, are they two competing protocols? Especially they were coming from two big players in the generative AI space. I didn't know if it was one of those things where it's like, all right, we're going to put these two protocols out there and see who can get better adoption and who wins out. But it was like, oh no, as I looked at it, they were actually, again, complementary, where you can use them together. So just to reiterate, MCP can handle accessing tools like whether it's external data, external databases, things on your local file system, and so on and so forth. And then A2A handles orchestration and delegation between the agents within the system. So they both have some similar advantages or similar, benefits, and like decoupling the models from the decoupling the model logic, enabling the multi-agent workflow, and then providing standardization in how communication happens. So here at the bottom is just a very simple way to think about it. MCP is talking to tools. Agent to agent is talking to the agents amongst themselves. So this diagram is not necessarily the best. I feel like some of the arrows got turned around as I generated this, but we can kind of see a very janky way of how they could physically work together. So again, we're starting here on the left, we have an agent. And again, we know agents can access tools, right? So this arrow probably should be pointing back here, but we're going to rock with it. And so we have an agent here. It can request a tool, but if this agent gets a prompt and it doesn't necessarily, let's say if it knows within that agent network that there's another agent that can handle this prompt better, it can delegate that task to another agent via that agent to agent protocol. So again, not the best diagram here. I'll have to go and clean this up before I share this out. But yeah, this is like the basic concept is that an agent can either use MCP to access a tool, or it can use the agent-agent protocol to delegate a task to a different agent. And here's some actual real-world use cases that where a system like this could be used. Um, One, you have a customer support system. So we've all probably had to be on the line with customer support sometimes and hear like those automated voices and all that. But here's a system that might can actually make that more useful. Is that if you hit like the first support agent, more than likely, because we've already heard like, how can I solve your problem today, or so on and so forth. That first support agent could then try to go to like their frequently asked questions, like that's probably stored in a database somewhere. So it can, use MCP to hit the database to come back with like answers to some of the frequently asked questions. Or if it need to go and fetch your data, it asks you for like, hey, what's your customer PIN or your, something, some personal information you look up. It can then interface with the CRM to go out and pull your customer data. So that's how MCP could work. Where the A to A part could come in is that after it pulls that data, let's say initially you called and like you got to the general customer support agent, but it's like, oh, it figures out that you now need to ask about billing. It could then take that CRM data, which it knows about you now, maybe it pulls some of your billing information, and pass that to the billing agent via A to A. So now it's handed off the information that is pulled to a different agent to try to solve your problem. And then that agent could have its own set of tools where it can go and pull information to try to help them solve your problem. So it can start to build out this workflow between pulling data, an agent pulling data using their tools via MCP, and then handing that off to the next agent, which could potentially use MCP to again pull data to help solve your problem. Another one of these examples that I particularly like is the travel planning one. Similar type thing, right? Where you could hit maybe the initial like general travel agent, and it can go and fetch information over like here are available flights for your potential destination, hotels, whatever, and then it can start to delegate. Because like you're probably given the initial information like here's my destination, and it can go and pull flights. But then it can also, as you give it that information about your destination, you can pass it to a separate agent. That agent can go pull hotels. You could then have another agent that goes pulls things from like activities that you could do. So you could just start to have like this chain where each one of those agents starts to pull information to basically build your whole itinerary for you and then give it back to you where hopefully now it's made planning. And you can, of course, give it a whole bunch of different parameters, right? You can say like, hey, this is my budget. Go plan a trip to Hawaii. And it can go out and each one of those agents can use their respective tools to build out an itinerary for you. So I hope that makes sense. So we're getting closer to like actually diving into some code. So I know I'm throwing a lot of information at you, so hopefully I can start to tie it all together once we jump into some code. But creating the actual agents. So there's a lot of different tools out there that's been come about in like the last 2 years or so. One of the first ones I used was called Crew AI, which was really nice. It had some really cool clean APIs for creating agents. You can create them using like LangChain, um, I think Llama Index. So there's a lot of different things out there you can use to create agents. What we're going to look at today is one that was just recently announced in like the last 2 months or so called Google's Agent Development Kit. So it's very flexible, very modular for developing and deploying agents, and it's agnostic. So this is the framework we're gonna use for our code example. And the actual demo we're gonna do. We're gonna build, well, I've already coded it, but just for time's sake, but we're gonna use a flow like using MCP. We're not necessarily gonna use A2A in this particular example, but we are gonna use MCP and like basically solving a problem that I have myself is sometimes I don't know what to wear. So especially with Atlanta weather, you just never know what's gonna happen outside. So it's like, okay, how can I have an agent to help me put that ish on, to help me, figure out what to dress for that, how to dress for that particular day. So we're gonna use a few different tools to get this done. So Conduit, oops, did I mean to zoom past that? Double clicking failed me right there. Um, Conduit, which I'll talk about a little bit. We won't spend too much time on it, but shameless plug. This is a tool that the company I work for created for fetching real-time data. And then we'll use that agent development kit that we briefly talked about, and we'll see how MCP will bring that all together. So we're gonna get out of the presentation and we're gonna jump over to code. So the first thing that we're going to define here in the code is we just have a very simple Docker compose file. And I've created just a Postgres database that's running locally on my machine via Docker. So, and this is going to be like our local data source. So remember we talked about in MCP that you can have a local data source or a remote data source. This is going to be our local data source that we're going to have. So I mentioned that tool Conduit. And as I reiterate, Conduit is a tool that the company I work for created, but it's open source and it allows you to build real-time pipelines to different data sources and move that to data destinations. So what we're going to do with that is we're going to use this to go out and get weather data. So again, another YAML file defining this data pipeline. So we have the concept of connectors. So connectors connects you to a data source or a data destination. So in this case, we have a weather connector that we're going to go out and we're giving it parameters for the city of Atlanta. And we're going to say we're going to poll weather every 5 seconds. Again, a bit of a contrived, nonsensical example because weather's not going to change for the most part within a 5-second increment, right? So we're going to be pulling a bunch of duplicate data. So again, just bear with me, a bit of a contrived example. And then once we go and fetch that data, we're going to put that data into that Postgres database that we're running via Docker. So let's actually do that because first I have the database over here in dbeaver, just a little open source tool to connect to the database. And we see right now the weather data is empty. So if we run Conduit, we'll go out and actually start to fetch. Oh no, we're not trying to do that. Some weather data. So we can look here in the terminal. We can see this weather record Again, it's happening every 5 seconds, but like I said, it's going to be a bunch of duplicate data where we can see it's going out and fetching the data. We can see temperature 78.6, max temp today is going to be around 81, and a bunch of other data. So if we stop that and we come back over here, we refresh, we can see that we now have some weather data in our um, database. Okay, why do we need that? Well, we want to know what we want, what should to wear today, right? And weather is a huge determining factor of determining what we should wear, right? So, in another table in the database, we have a wardrobe table. So, what I did here, I just went and grabbed the website links to a bunch of my favorite clothing brands and pasted them in and said, hey, go give me some example clothes from these different websites and put these different parameters for them. The one exception is the shoes. I don't, I took away the little thing, but like these are actually some of the shoes I own. So like my shoe collection that's over my shoulder is playing into my into my presentation today. So yeah, I basically wanted like how can I build a database of clothes so now whenever I ask the agent what should I wear, it has the data to pull from to tell me what I should wear. So let's jump back over into the code where we actually see where we define the agents. So this is where the ADK part comes in, the Google Agent Development Kit. So we have a bunch of imports in. As we see, I'll just do a quick scroll under 100 lines of code to build out these agents. So we have this async function here. And what this is going to do, this is going to define our root agent. So let me actually work a little bit backwards first. So first, we want to define, you can have a root agent and then you can have sub agents. So the root agent is going to be kind of like your entry point, excuse me, and that's going to be, and then those sub agents are going to be basically agents that the root agent can delegate to. So like I said, we're not using A2A explicitly, but I think like given that this is coming from Google, I think the A2A protocol is used underneath the hood here. So we first have our PTSO agent, which is going to be our root agent, and we're defining it with something called sequential agent because they have different types of agent classes that you can define them as. So you can have what's called like a just a straight LLM agent, and what that does, it will try to intelligently delegate within the network of agents. The problem with that is that the and some of the challenges of working with LLMs in general is that things are non-deterministic, meaning that you may get a output close to what you're expecting, but it's never going to be exact. Or like, let's say if you make the same request twice, you can get an output that's going to have the same sentiment, but it probably won't be word for word the same. So with the LLM agent, it will try to intelligently delegate to other agents, but it may actually skip over agents sometimes. So what we're using sequential instead to say like these sub agents that we define here, we want you to use them in order, in a specific set order. And so from there, we're saying we want to use weather agent and then wardrobe agent. So the weather agent, we define its all its attributes, and but then we also have instructions for that weather agent. So, and this is just a system prompt essentially, where if you've worked with like ChatGPT or anything like that, where you can kind of give it a system prompt to just give some guidelines. This is just kind of an explicit system prompt as far as like how to work with um this particular tool that you have, or define letting you know the tool that you have access to. Same thing with the wardrobe agent. We also have instructions for it as well. And trying to tell, hey, this is what we have and how and some like some guidelines around it. So if we go back up, like I said, working backwards a little bit, we have this async function, which is gonna again create and configure the root agent and all of its sub agents. So we have this exit stack, just sort of like if something goes wrong, it rolls it all up to be able to exit. And then we are defining our MCP tool set. So a lot of MCP tools are written either in Node, so in JavaScript, or in Python. In this case, I was able to go and download a MCP Postgres server. So I didn't have to write this myself. Like I said, this is where that reusability modularity comes in. Someone has already written this for me. So I just go and download it. And I basically just say, you can run this using npx. So basically it's written in Node. So use the Node command to run this MCP server. So this is defining our weather tool. And then just the same, because we're also pulling our wardrobe data from Postgres, using that same MCP tool, and we give it the connection string to that database that we looked at already in dbeaver, and this is our wardrobe tool. And then if we get all the way here, again, that's kind of all defined. Actually, all that's defined in that get async agent function. Where we define and from here we can return the PTSO agent, which is the root agent. And then so outside of that function, this you can think about this. I guess I didn't put it in like a main block or a main dunder or anything, but like this is where we actually instantiate the agent by calling that function. So again, hopefully I explained that well. Again, willing to talk about it afterwards, but for now, just in the sake of time, I know I've talked a lot. Let's run it and see what happens. So we can run it with the command adk web. And so what that does, it runs the code. And one of the niceties about ADK, it provides a little UI for you that you can go and actually kind of see and interact with your agents. So let's open this up. And this is a little interactive UI that we have. Let me close that other instance. And we can go and select our agent, so the PTSO. And hopefully this works and doesn't embarrass me. What should I wear today? So it goes out. We look at was it sessions or events? Okay, we can kind of see it in events. It goes out and hits our first agent because it's like, okay, I need to know where you are to be able to get the temperature first. Makes sense. So I'm in Atlanta. So we can kind of see some of the observability that we talked about before, right? Is that it goes out and it's like, okay, you're in Atlanta. Let's go hit the database and query for that. So yeah, we can actually go and see kind of the patterns that it's using. So from our root agent, it knows it needs to go use the weather agent. It writes this query for me. Like I didn't have to go and, write a SQL query or whatever. So it writes that query. Let's see. Yeah, here's the actual query. So we can see in the observability of what it's doing. It goes and writes that query to hit the database, and it comes back and says like the latest data we have on the temperature in Atlanta is 78.6 degrees, which we saw that before, right? Whenever we ran Conduit to go and fetch that. So now it says that's hot. So I'm recommending lightweight, breathable clothing. So the next thing it does is we can see now it's delegating to the wardrobe agent. And from there, it's going to write a different query to hit that wardrobe table that we saw to try to find clothes that fit this recommendation. And from there, we get that information back. And now it formats it out into like a nice human readable response where it says, like, okay, if you want to go comfortable and casual, here are some clothing options from your clothing database or the things that's in your closet. Or if you want to, jazz it up a little bit, be slightly more dressed up, here's some options. Or if you want to just go like very, athleisure, here's some other options. So we got to see from the observability standpoint, this root PTSO agent delegating to the different agents and how they're then using MCP to interact with that Postgres database that we had. So this is just a very simple example of how those protocols can interact together, and you can build multi-agent systems to solve a task.
As you are switching back, Will, we got a question in the chat. Uh, I apologize in advance, and I hope you correct me, but Zana is my instinct of how to say your name. Are there any recommendations for a remote data source or cloud data source for building servers if you don't want to host it locally with like a dbeaver?
Could I hear the question one more time?
There.
Because I would say we are done with the presentation, so we can totally just
Oh,
go right into. So that was the last thing to show. So like my next slide was going to the Q&A, so we could totally get into that now.
thank you. Um, yeah. So, oh, let's see. Did I get a correction on the name? Not yet. So, are there any recommendations for a remote data source or a cloud data source for building servers like this if you don't want to host your data locally?
Yeah, you can use pretty much any remote data source. Like I was using a Postgres database that was running locally on my machine. You can use a Postgres database that's whether you have it deployed on AWS, GCP, any of those type of things. So like yeah, like I could take that same exact database that I had there and like I said, deploy it to a cloud service and it should work just the same. I would just have to update the connection string so it then now connects to a remote service to that remote connection string where it's running on let's say Amazon AWS instead of it connecting locally to where I have it running now.
Thank you. I hope that answered the question, but please prompt us if we did not fill in the gaps here. Mary, welcome back. Mary is asking, what are security considerations we need to think about with the agents?
Yeah, sensitive data is always like one of the security issues, right? So you want to be, cognizant around the data that you're passing because one of the things that we talked about is at least we saw an example is using personalized data. But there's some personalized data I don't want access to. Like it having data around my wardrobe, I'm mostly fine with that. But as it gets a little more dicey around like any type of PII or anything like that, you always want to be cognizant of that, of what data you expose to it.
That is a good point. Actually, something else that at least I know I worked in healthcare before, something we have to think about is things that in and of themselves are not sensitive, but when you combine it with another data
Hmm.
set, it identifies the person basically.
For sure.
Um, so yeah, that's another one. All right, any other questions? Also feel free to unmute if you're brave. You don't just have to drop these in the chat. Oh, we have a ADK, so the development kit versus Crew AI for multi-agent workflows question. That is from
Yeah, great question. Great question, Bill. Again, I like ADK. Again, it's very new. I liked it because we were able to get that observability that we talked about. We were able to get the visual of the workflow of how the agents were interacting with one another. So that's definitely great for demo purposes. Given that ADK is very new, it's one of those things where it's under active development, it's in beta. They always say, use it at your own risk because it can have breaking changes. Crew AI is a little more mature at this point. That people have been able to use it in production, put it out there, has great documentation, a lot of resources, even like on YouTube and such. So it's one of those things where, yeah, like Crew AI is a more mature product at this point, which I think they even probably have managed solutions as well. where of course you can go and use it open source style and build yourself. But I think they even have like a managed interface at this point as well. But yeah, Google ADK one. I used it because it was like something new, but then once I kind of saw the UI, I was like, I think this would be great for demonstration purposes. It's so new, I can't say I recommend it for like building in production yet, even though it does mention how like it's agnostic and allows you to be model agnostic, so you're not locked in into like one particular model, even though Google obviously has Gemini, but you're not locked into using Gemini, and it's also you're not locked into like any type of deployment um vendor lock-in around deployment. So you don't have to deploy it on GCP. You can deploy it on Azure. You can deploy it on AWS. So, but I can't speak to um, how people have used it in production yet.
All right, we have quite a few more questions if you can stay with us still.
Sure.
Uh, so, Mary is asking what other types of projects should we think about starting with this workflow?
Um, it's kind of like whatever your creativity can come up with, right? Like I said, I came up with the PTSO agent just trying to solve one of my own problems of like, what do I wear today? So that's always a good starting point of like, man, what what is something that I know I need to do, but I do not want to think about it? Like if I could outsource my thinking on this to something else, um, what is it that I can do? So there's definitely, other different things. I know we had like the four examples, like the travel agent, the customer service and stuff. I've even seen some ideas around like well, I'm blanking on it. Why am I blanking on this? Like at work of using it for like automatically triaging, say like if a security alert or something comes in, automatically triaging and going through like our run books to try to remediate any type of like whether it's a service alert, security alert, or anything like that. So yeah, like I said, I would say just think about something, just a problem that you have. And I think that's the starting point, and then just let your creativity flow from there, like how you can use tools like this to potentially solve them.
Hey, thank you, Mary. I see your second question, but let me get to Zaina's first. Thank you for correcting me. Is there a way to protect sensitive data, like creating fake data or encryption? So it sounds like two questions, like how do we protect, and also what ways can we create fake data?
For sure, and see a great recommendation on Faker. I've used Faker, and it's a really, really good tool. I've run into this problem quite a few times, like at work, where if I'm working on something that's around particularly sensitive data, whether it's around uh, medical data, whether it's around like military data. Obviously, I can't get access to that type of stuff, and nor should I want to because that's real sensitive data. So I can use things like Faker. You can even have ChatGPT or something like that now to kind of say like, hey, generate me some data, especially if you know the general structure of it because especially like it feels like that medical data, military, whatever, they're gonna have a particular schema and structure that the data needs to adhere to. So and Faker, you can do that as well. You can define like the structure of how the data should be generated. Um, just the same, the tool that I use to go and fetch the data conduit, again, that's what we, use internally. We what's it called? Like eating your own dog food. We created that tool, but we also use it ourselves. We have a generator connector where we can define a schema and it's similar to Faker where it will just generate just constantly on some interval new data. So you can use that for testing. And of course, you can always do encryption and stuff as well. So, like again, another problem we run into at work. We have data flowing through a pipeline. The data, some of the data may have sensitive information. We can encrypt certain fields. So we can say like, um, again, let's use the medical example. If we have some medical data coming over the wire, of course, you may want to, the first name, last name, yes, they can be PII as well. But let's say particularly like a social security number we could identify that field and encrypt it in real time. So, and you can do the same thing, right? If you're using Faker or some other generative tool to say like, hey, certain fields, Like we see it all the time, right? Where it may have just like the star, 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 and then like the last four digits of the social security number or something like that. And then also you can think about different ways to store that encrypted data in the database, right? Because you don't want to store sensitive things like that in plain text. So, yeah, there's definitely ways around that, especially if you're trying to work with something that the data is particularly sensitive. Um, yeah, especially just in the debugging testing phase, highly recommending using tools like that to mock out the data and then go from there.
Thank you, William. And it seems like Mary is trying to automate her whole life. So she's trying to figure out if this workflow you just showed us is brittle or if there will be a lot of debugging. I imagine there'll be some debugging, but what things can we learn as we get into it about how to debug?
Yeah, and again, that's why even going back to Bill's question, why I enjoy like for even just for prototyping phase, something like that, using ADK because you get to see the observability, right? We got to see which agent it was delegating the task to. We got to see the actual query it was generating to interact with the database. So from there, again, part of this, we want to try to keep the implementation details out of the prompts as much as possible. It's not always completely possible to do that because, yeah, you may have to go and modify that system prompt that we saw earlier, those instructions to say, like, hey, because okay, for example, one that I've come across in testing this is that it'll say, like, oh, it's hot outside. Let me go find you some, breathable clothes. And in my database, I don't think, like, I had materials as a column and some of them would say like 100% cotton or something like that, or 98% cotton, 2% this, whatever. But none of them just said the word like verbatim cotton, like only that. So then sometimes it would come back to me and say like, oh, I couldn't find any cotton clothes in your database, so which is not accurate, right? It's like it may not, the column itself may not say strictly exact word match cotton, but there's cotton in the description. So that's one of those things like, oh, do I need to update the system prompt to say like when you're querying, you don't necessarily have to do a equals query. You may can do a like query to say like if the material contains the word cotton, it doesn't have to be an exact match on that word. But I wouldn't necessarily know that if I didn't have that observability and see the query that it was that SQL query that it was generating. Because then I would be very confused. I was like, what do you mean that I don't have any cotton clothes? Like, and when I go look at the database. So yeah, there's gonna always be some level of debugging whenever you're working on something. So, but yeah, that's why I think ADK is pretty slick, just because it gives you better insight. It's a little less of a black box when you're trying to debug.
This sounds great. Um, any last questions here? As we are waiting, I would also like to, once again, if you've been in any of our sessions, we have a survey because we want to know how this went for you and for us, and maybe for Will. Maybe he wants to know. William, by the way, I apologize. I have been changing your name here and I did not ask you what your preference is.
I'm
So I'm
fine
going
with
to
either.
the
I'm fine.
official.
William or Will is totally fine. I'm fine with either.
Okay. So yeah, thank you all. If you could help us out with this survey, we would appreciate it. If there are no other questions, I can let you all go because we have one more session that starts in a minute. With the founder, uh, Kim, and she's going to be going over how you can automate your life a little bit more with ChatGPT. Be more intentional with the prompts you give it. Thank you so much. And Will, thank you. I wish you all a happy Juneteenth, a restful day, a day of learning. We will share any tools or any resources that will, now I'm second guessing this, gives us with you once the session is processed. This recording is processed. Yeah.
Yeah, thanks, y'all. I really appreciate it. Thank you for having me.